In a previous video, we had shown how the square root method could be used to solve an equation rather simply by taking the square root of both sides. And unfortunately, it could only be used when the middle term was missing. That is, that there was no term that had an x to the first power. And in this equation, we do have a middle term, so we cannot use the square root method directly. But if we were able to package this trinomial into a perfect square that had something in parentheses equal to some number, then we would be able to use that square root method. And I'm going to cheat a little and just note the fact that if I had x plus 5 times x plus 5, that would then give me x squared plus, and then using FOIL, our two outer terms, 5x plus 5x gives us 10x plus 25. And so, had this trinomial had a 25 here, we would have our perfect square. However, we can imagine that the number 31 is divvied up into 25 plus 6. And so, if we were to put the first three terms together, that would be our perfect square. That would be our x plus 5 squared. And then the plus 6 on the left-hand side could be subtracted from both sides, and we'd end up with a negative 6. And then we could solve this problem by taking the square root of both sides, that x plus 5 is equal to the positive or negative square root of negative 6. And so isolating, we would get then that x is equal to a negative 5, and then plus or minus, and the square root of that negative becomes I, and then we have square root of 6 inside. So then the question becomes, can any quadratic equation be converted into a perfect square? And the answer is yes. And the procedure that we use to make this happen is called completing the square. So we're going to step by step work through this procedure on a simple example. So here we have x squared minus 8x minus 2 is equal to 0. The first question I ask myself is, can I factor it? The answer is no. I can't get factors of 2 to have a difference of 8. The second question is, can I take the square root of both sides? And the answer is no, because I don't just have a square term and a constant. I do have this first x to the first power. So I can't use factoring, can't use square root method, so I'm going to complete the square. First step says get the equation in the form x squared plus bx equals c. So I want to get my square term and my linear term, my minus 8x on the left side, and on the right hand side it says put the constant there. So I'll add 2 to both sides and I get equals 2. Second step, and this is a very critical step, it says find the needed number to complete the square. And so this needed number is b, the coefficient of the middle term, and I don't really care about the sign, but I'm just going to take that 8 and divide it by 2. And then I'm going to square that, and so this is equal to 4 squared, which is 16. Next, step 3 says that we should add that number to both sides of the equation. So I have x squared minus 8x plus 16 is equal to 2 plus 16. Step 4 now says factor the perfect square. So we are assuming that if we chose the correct needed number, I should get a perfect square on the left. And when I package that up, I get x minus, and this becomes 4 here. And so note that the needed number, when we took this b divided by 2 and then squared it, that b divided by 2 is the number that we're going to put inside here for the binomial factor. And on the right, we just have 18. And now we're going to finish this by using the square root method. Step 5 says to square root both sides, or take the square root of both sides. So we have x minus 4 is equal to, and we do need to get positive or negative square root of 18. And we can simplify that by making it plus or minus 3 root 2. So when we isolate the x, finally solving it completely, we get x is equal to, adding 4 to both sides, positive 4 plus or minus 3 square root of 2. When we look back on this, there are a couple things to note. One is that this needed number is very important because if we get the correct number added and we make a trinomial that's a perfect square, it will package up into a set of parentheses that looks like a perfect square. If we don't add the correct number here, we won't be able to package this up into a square. Another thing to note is that when we have a problem where we want to complete the square, having an even number here for the middle term is very helpful because when we find our needed number, when we take that coefficient b, divide by 2, if it's not an even number, we end up with a fraction and then we square that and get an even more complicated fraction. So complete the square can become very tedious and very difficult depending on the problem, and we will show you other methods for solving this type of quadratic equation.